All right, so we have y equals the square root of -9 minus 3x. So first, let's rewrite this square root so that we have an exponential representation. So this is going to become y equals this -9 minus 3x to the 1/2 power. Okay, so on the chain rule, if you'll remember, if I'm taking the derivative of a composition, so f of g of x, it's going to be f prime of g of x, so the outside derivative, the inside stays the same, times the derivative of the inside, okay? So I think on a problem that I re-recorded from the lecture, I talked about how this is like an implosion, okay? We're like caving in on itself, and on every time we move in another layer, we're taking another derivative, okay? So here, y prime, I first take the derivative of this outside function, what I've written in pink. So it's 1/2, the middle stays the same. Subtract 1 from the exponent to get a -1/2. Then I multiply that by the derivative of the inside. Well, on the inside, the derivative of -9 is 0, and the derivative of -3x is -3. Now I can clean this up, and we're going to have this 1/2 times -3 is -3 over 2. And this -9 minus 3x to the -1/2, we're going to move that down to the denominator and make that exponent positive. So you can leave your answer like this, or you could say -3 over 2 root -9 minus 3x. Either way would be just fine. Number 2, I have sine of 8 pi t over 7 plus cosine 8 pi t over 7. So I technically have two chain rules here, okay? On both of these, my trig function is that outside function, okay? And that 8 pi t over 7 is my inside function, okay? So we're going to implode. We're going to take the derivative of the outside and then the derivative of the inside. We're just kind of working our way in. So S prime is, well, the derivative of sine is cosine. Keep the argument the same. Okay? The derivative of 8 pi t over 7, that's like t having a coefficient of 8 pi over 7, so that derivative is just 8 pi over 7. Plus, the derivative of cosine is negative sine of something, of what? That original argument. Okay? And then we're going to multiply that by the derivative of the inside. So the derivative of 8 pi t over 7 is just 8 pi t. So now we'll just work on cleaning this up. Couple of ways we can go about this. I'm going to just factor out this 8 pi over 7. So I'll bring that out. That divides those out. So then I'll have cosine of 8 pi t over 7. And then plus a negative is just going to be minus sine of 8 pi t over 7. Number 3, I have y equals x squared sine to the 4th plus x cosine to the -6x. Now, this one's a little complicated, okay, because I have two terms that are being added, and both terms individually have a product rule, okay? So what I would recommend is setting this apart. So because we know ultimately when I take y prime, what's going to happen is, because we have a sum, okay, by the sum and difference rule, remember that's just going to be the derivative of each part, right? So I'm going to take the derivative of x squared sine to the fourth x, and I'm going to add that to the derivative of x cosine to the negative 6x. Okay? So it might make more sense here to split these up momentarily. Like, figure out what the derivative of x squared sine to the fourth x is. Figure out what the derivative of x cosine to the negative 6x is, and then put them back together. Because ultimately, because of the sum and difference rule, I know that I'm just going to be adding their derivatives together. So let's do that, okay? So for this first one, if I'm taking the derivative, let me give myself some space here. If I'm taking the derivative of x squared sine to the fourth x, okay, that is a quotient rule, where x squared is my first and sine to the fourth x is my second, okay? And so it's going to take a little bit of work to figure out what these are. So f is x squared, g is sine to the fourth x. Well, isn't that the same as saying sine x being raised to the power of 4? If I have that 4 between my argument and the trig function, that means I'm just raising the entire trig function to that exponent. Okay, so for f prime, I'm just going to have 2x. But for g prime, I have a little work because I have the chain rule. So first I take the derivative of the outside, so 4 sine x cubed, and I'm going to multiply that by the derivative of the inside. So the derivative of sine x is cosine x. So we'll clean up g prime, and it becomes 4 sine cubed x cosine x. Okay? So I'm not done because remember, I'm trying to find the derivative. And this is a product rule. So on a product rule, we know that we're going to have first times derivative of the second plus second times derivative of the first. So that's going to be x squared times 4 sine cubed x cosine x plus sine x to the fourth. Remember, that was the same as sine to the fourth x times derivative of the first is 2x. Okay, so we've done that. I could clean this up and say that this is 4x squared sine cubed x cosine x plus 2x sine to the fourth x. All right, let's do the next part. So if I find this derivative of x cosine to the negative 6x, okay, x is my f, cosine to the negative 6x, this is my g. So we're going to say f is equal to x, so that means f prime is equal to 1. G is equal to this cosine to the negative 6x. So remember, that's the same as taking cosine of x and raising it to the power of negative 6. When I do that, I can more easily see that, hey, this is a chain rule, okay? So we're going to get g prime, we're going to use the chain rule. So I take the derivative of the outside, so negative 6 cosine x. I subtract 1 from the exponent to make that negative 7, okay? And then the derivative of the inside is negative sine x. So I'm going to clean up g prime, and I'll have this negative 6 times negative sine x is a positive 6 sine x. And I'm going to leave it in negative exponents for now. We'll change it at the end, but this cosine x to the negative 7 is cosine to the negative 7x, okay? So for this part, if I have f g prime plus gf prime for the product rule, that's going to give me x times 6 sine x cosine to the negative 7x plus, give myself more room again, plus cosine, let's see, cosine to the negative 6x times 1. Okay, so when I clean this up, I'll have 6x sine x cosine to the negative 7x plus cosine to the negative 6x. So remember, our whole point is we're trying to find the derivative of our original function. So now these two parts that we found, we're going to add those together. So our y prime equals 4x squared sine cubed x cosine x plus 2x sine to the 4th x. So we got that part. Now we're going to add in this part plus 6x sine x cosine to the negative 7x plus cosine to the negative 6x. Now, let's see, kind of lost my spot here. All right, so just checking my work. We could try to go in and simplify, but there's really nothing to simplify here. Now, just make sure, so on the PDF, it does give a negative exponent as the answer choice, but on the test, I'm going to want you to rewrite with positive exponents. So our final answer would be 4x squared sine cubed x cosine x plus 2x sine to the 4th x plus 6x sine x over cosine to the 7th x plus 1 over cosine to the 6th x. Are there other ways I could clean this up some more? Sure, but I would take this as a final answer. I'm not going to give one this crazy on the test. Like I might have something that's like, you know, a sum of a product rule, but I'm not going to give you a sum of a product rule where both of the terms have a chain rule. Maybe one of the terms, but not both. That's just too much to me. Okay, number 4, we have y equals 1/15 times 5x minus 4 cubed plus 5 minus 1 over 4x to the 4th to the negative 1. Okay, so unlike the last problem, this is just that sum and difference rule, okay? And on both of these, I have a chain rule. So if I rewrite, if I rewrite this, for my first term, 1/15 is just a constant multiplier, okay? My outside function is this something to the power of 3, and my inside is this 5x minus 4 that's being raised to the power of 3. Plus, same thing here, my outside function is this something to the negative 1, and my inside function is this 5 minus. Now here, when I get to where I'm having to take the derivative of 1 over 4x to the 4th, it's going to be better for me if I rewrite x to the 4th with a negative exponent. So I'm going to write this as 5, because that looks like an S, doesn't it? I can't, 5's and S's. 5 minus 1/4, okay, because we can look at this as a constant multiplier, and then I'm going to have x to the negative 4, okay? All right, so when I'm finding y prime, for my first term, I keep the constant multiplier. Then I'm going to take the derivative of the outside, so that's going to be 3 times 5x minus 4 to the second power, because we subtracted 1 from the exponent. And then I'm going to multiply that by the derivative of my inside function, which is just 5. Plus, we're going to do the same thing over here. The derivative of this outside function, I bring that negative 1 out front. I keep the inside. And then I subtract 1 from the exponent to get negative 2. Now I need to multiply by the inside function, okay? Well, for my inside function, this negative minus 1/4, this negative 1/4 is a constant multiplier. Then wouldn't I bring that negative 4 out front, keep the x, and subtract 1 from the exponent to get a negative 5, okay? So I know this looks like a lot, but this is definitely within the skills that we've learned so far in this course. So let's just clean it up, okay? So when I'm looking at this, I notice that 3 times 5 is 15, and 15 times 1/15 cancels out, so those all go away. and I have 5x minus 4 squared, okay? So then I'm looking at this other part. I have this negative 1, and negative 1/4 and negative 4, those cancel each other out. So this negative 1 is actually going to make this a minus problem, or a minus instead of plus, and then I'm going to have a 5 minus 1 over 4x to the 4th, because that's what this was originally, to the negative 2 times x to the negative 5. Okay? So I can clean up those negative exponents. So I have y prime equals 5x minus 4 squared minus 1 over x to the 5th times 5 minus 1 over 4x to the 4th squared. All right. Number 5, we have y equals 3x e to the negative 2x minus 3 e to the x cubed. Okay. So I'm adding two terms. All right. So I'm going to have to take the derivative of this term, and then I'm going to be subtracting it from the derivative of this term. Okay. So here, you know, it might be nice to come out and say, okay, well, let's look at these separate. Let me take the derivative of each part and then put them back together. So the derivative of 3x e to the negative 2x, okay, well, that's going to be a product rule, okay, where 3x is my first function, e to the negative x is my second function. And then we'll also be taking the derivative of this 3e to the x cubed. And we'll look at that in just a moment. So for this first 3x e to the negative 2x, I'm going to let f be 3x. And g is going to be e. So the e is my inside, and then e is my outside function, and negative 2x is my inside. Okay? So f prime is just 3, and g prime is, well, the derivative of e to the something is e to the something, and then we're going to multiply by the derivative of that inside, which is negative 2. So that makes g prime equal to negative 2 e to the negative 2x. Okay? Now, the second part here, well, actually, I didn't finish the first part because this first part's a product rule. So we're going to have first times derivative of the second plus second times derivative of the first. So that's going to be 3x times negative 2 e to the negative 2x plus e to the negative 2x times 3. So when I clean up that first part, I'm going to get negative 6x e to the negative 2x plus 3e to the negative 2x. For the second portion up here, I can rewrite this 3e to the x cubed. 3 is a constant multiplier. E is my outside function, and my inside function is x cubed. So when I take the derivative, I'm going to have my constant multiplier of 3 times the derivative of e to the something is e to the something, and now we multiply by the derivative of that something, or that inside function, so it's 3x squared. So I'll clean this up and get 9x e to the x cubed. So if you remember, in my original problem, I'm subtracting. So since I'm subtracting, when I take their derivatives, I need to be subtracting their derivatives. So I'm going to have y prime is equal to the derivative of that first term, which is negative 6x e to the negative 2x plus 3e to the negative 2x, okay? And then I'm going to subtract 9x e to the x cubed, okay? Oh, 9x squared. I left because it was 3x squared times 3. My apologies. So, for us, we will rewrite negative exponents positive on the test. So we'll have negative 6x over e to the positive 2x plus 3 over e to the positive 2x minus 9x squared e to the x cubed. If you wanted to combine these two into one fraction, you can, but you don't have to. But this is our final answer. Number 6, we have f of x equals negative sine x over 1 minus cosine x squared. So, of course, here we have a power rule again. Chain rule. So, for our chain rule, I'm just going to color code it here. Something squared is our outside function, and negative sine x over 1 minus cosine x is our inside function. And our inside function happens to be a quotient rule. So we know that when we do a quotient rule, we have to label our parts. We have to label f and g, f prime and g prime. So if f is negative sine x, then g is going to be, well, if the derivative of sine x is cosine x, then the derivative of negative sine x is going to be negative cosine x. Oop, not g, f prime. If g is 1 minus cosine x, then g prime is, okay, I have negative cosine x because we know the derivative of 1 is 0. So if the derivative of cosine is negative sine, then the derivative of negative cosine is going to be positive sine. Okay? And now we're ready to find the derivative. So f prime of x is going to be the derivative of the outside. Again, you're probably screaming at me because I just didn't follow what I said. The derivative of the outside, I bring the 2 out front. I keep the argument. I subtract 1 from the exponent to get a 1. And then that's times the derivative of the inside, which is my quotient rule. And remember, on the quotient rule, we have low d high minus high d low over low low. Okay? So that's low. And I guess I shouldn't have, let's see. I kind of crossed out some stuff that I shouldn't have because we still need it for this problem. My apologies. 1 minus cosine x. Okay, so we're going to have low d high minus high d low all over low low. Okay, so that's going to be 1 minus cosine x squared. We had a problem similar to this on the classwork problems. So now I've done the chain rule. I've just got to clean this guy up, okay? So we'll have 2 times negative sine x over 1 minus cosine x is negative 2 sine x over cosine x. Then in the numerator, I've got to clean up. So 1 times negative cosine x is negative cosine x. Negative cosine x times negative cosine x is positive cosine squared x. Minus a negative sine x times a negative sine x is going to be plus sine squared x. And all of that's over 1 minus cosine x squared. Okay? Oh, this is over 1 minus cosine x. I wrote that down wrong. I'm sorry. Okay. So now cosine squared x plus sine squared x is equal to 1. So I can rewrite this as negative 2 sine x over 1 minus cosine x times negative cosine x plus 1 over 1 minus cosine x squared. Now, isn't negative cosine x plus 1 the same as 1 minus cosine x? So those will cancel out. And we're left with negative 2 sine x over 1 minus cosine x squared. Number 7, we have y equals cosine of e to the negative 5 theta squared. All right, so here we've got some layers, all right? We have a chain rule within a chain rule. So my outside function is this cosine of something. Inside that, I have e to the something, okay? So I'm going to work my way in with the derivative, so it'll be pink, blue, green, okay? So y prime, the derivative of cosine is negative sine of the same thing, okay? Times, we're going to work our way inward. So the next layer inside is this e. Well, the derivative of e to the something is e to the something. And then we're going to multiply by the derivative of negative 5 theta squared, which is negative 10 theta. So when I clean this up, I'm going to have, let's see, negative 10 theta e to the negative 5 theta squared. And since this is a negative sign times a negative 10 theta is actually going to be a positive number, so I should have made that positive. So times sine of e to the negative 5 theta squared. Now we're going to represent our answer with only positive exponents. So what stays up top? 10 theta stays up top. Sine, since sine is not being raised to a negative exponent, it's going to stay up top. But that argument, e to the negative 5 theta squared, I can write that as 1 over e to the 5 theta squared. And this will all be over e to the 5 theta squared. Number 8, we have a chain rule with a product rule on the inside, okay? So when I rewrite this, what's my outside function? Well, my outside function is something to the power of 10. My inside function is this t times secant t, which that is a product rule, okay? So since we know that we're going to have to use the product rule, let's just go ahead and find those parts. So if f is t, then f prime is 1. If g is secant t, then g prime is secant t tangent t. All right, and we're ready to use our rule. So y prime, we're going to start with the chain rule. If I bring the 10 out front, I'm going to have 10 t secant t to the power of 9. And then I'm going to multiply that by the inside, the derivative of the inside of the function. Well, that is my f first times derivative of the second plus second times derivative of the first. So we're going to have t times secant t tangent t plus second, which is secant t, times derivative of the first, which is 1. All right, so we're going to clean this up. I get y prime equals, let's see. We'll have 10. Really, we just have what we have here. 10 times t secant t to the 9th times t secant t tangent t plus secant t. And that's our final answer. Number 9, we have y equals t cubed over t to the 4th minus 2t cubed. Okay. So on this one, we have a chain rule. Whoops. We have a chain rule where my outside function is this something to the 3rd power, and my inside function is going to be a quotient rule. okay? Where t cubed is my numerator, g or my denominator is this t fourth minus 2t. So f prime is going to be 3t squared, and g prime is going to be 4t cubed minus 2. All right. So y prime, we're going to take the derivative of the outside, which is 3t cubed over t to the fourth minus 2t, and we subtract 1 from the exponent. Now we're going to multiply that by the derivative of the inside, which is a quotient rule. Okay, and remember on the quotient rule we have low d high. Whoops, why is that not working? Low d high. Wow, I think maybe low d high minus high d low over low low. So we'll have low d high minus high d low over low low. So t to the fourth minus 2t squared. Okay. This one, there's a lot of cleaning up we can do. Okay. So first, I have y prime equals 3 times t to the third power squared is t to the sixth power over t to the fourth minus 2t squared is t to the fourth minus 2t squared times. In my numerator, let's distribute. So t to the fourth times 3t squared is 3t to the sixth. Negative 2t times 3t squared is negative 6t cubed. Then we're going to have minus t cubed times 4t cubed is 4t to the sixth. T cubed times negative 2 is negative 2t cubed. I put this in parentheses because there was a minus sign here, okay? So whatever follows needs to go in parentheses to make sure that we distribute the negative correctly. So this is all over t to the fourth minus 2t squared. Okay, so I'm still cleaning this up. So I have y prime equals, all right, in the numerator of this first fraction, I'm going to have 3t to the sixth over t to the fourth minus 2t times, I'll have 3t to the sixth minus 6t cubed. I'm distributing the negative, so that's minus 4t to the sixth plus 2t cubed. And all of this is over t to the fourth minus 2t squared. Okay, so that's 3t to the sixth over, oops, that was supposed to be squared, over t to the fourth minus 2t squared times 3t to the sixth minus 4t to the sixth is negative t to the sixth. Negative 6t cubed plus 2t cubed is minus 4t cubed. All of that is over t to the fourth minus 2t squared. Okay, so what we can do now is we can start combining things. So I can multiply this 3t to the sixth by this function, okay? So 3t to the sixth times negative t to the sixth gives me a negative 3t to the 12th, okay? Then 3t to the sixth times negative 4t cubed is negative 12t to the 9th. And all of this is over when I multiply t to the fourth minus 2t squared times t to the fourth minus 2t squared. That's t to the fourth minus 2t to the fourth. Okay, so this next part can get a little tricky because if I'm looking at this, if I look at this t to the fourth minus 2t to the fourth, okay, could I rewrite that as t times t cubed minus 2t to the fourth? Which if I distribute that exponent of 4, that would be equivalent to t to the fourth times t cubed minus 2t to the power of 4. I'm just using algebra. I'm not using any calculus, just algebra. So what that means is in my numerator, I can actually factor out a negative 3 t to the 9th, okay? And that's going to give me a t cubed plus 4, okay? And in the denominator, I'm going to rewrite my t to the 4th minus 2t to the power of 4. I'm going to rewrite it the way I have here. So I'm going to have t to the 4th times t cubed minus 2t to the power of 4. Well, t to the 4th will go into t to the 9th, and we're left with a t to the 5th. So this cleans up to be negative 3 t to the 5th times t cubed plus 4 over t cubed minus 2t to the power of 4. And that's our simplified final answer. All right, on number 10, I have a chain rule within a chain rule. If I rewrite this in color coding, my outside is cosine of something. My next layer inside is tangent of something. And then my last layer inside is this 5t minus 2. Okay? So then y prime, okay, we're just going to take the derivative and work our way in. So the derivative of cosine of something is negative sine of something. Keep working your way inside. The derivative of tangent of something is secant squared of something. Lastly, the derivative of 5t minus 2 is just 5. So we'll clean this up. We're going to have a negative 5 sine of tangent of 5t minus 2 times secant squared of 5t minus 2. Here we have y equals 2t times 3t cubed minus 7 to the 5th. So this is a product rule, okay? So we're going to have to figure out, well, what is f and what is g? What is f prime? What is g prime? Okay? Well, f is 2t. G is 3t cubed minus 7 to the power of 5, where something to the power of 5 is my outside, and then 3t cubed minus 7 is my inside. So f prime, so if f is 2t, f prime is just 2. G prime, I'm going to go outside in. So the derivative of the outside is 5 times something to the 4th, okay? And then we multiply that by the derivative of the inside, which is going to give us a 9t squared. So when I clean up my G prime, I get, let's see, 5 times 9t squared is 45t squared times this 3t cubed minus 7 to the power of 4. Not done, because the whole reason of doing this was to use that product rule. So we know that y prime is going to be first times derivative of the second plus second times derivative of the first. So y prime is 2t times 45t squared times 3t cubed minus 7 to the 4th plus second, which is 3t cubed minus 7 to the 5th times derivative of the first, which is 2. So when I clean this up, I'm going to have 90t cubed times 3t cubed minus 7 to the 4th plus 2 times 3t cubed minus 7 to the 5th. Now, on this problem, I can actually clean some stuff up, okay? The first thing that I notice is I can factor out, how do I want to go about this? I can factor out, let's do it this way. I can factor out a 3t cubed minus 7 to the 4th power, okay? So when I do that, when I factor that out, okay, that cancels it out completely here. So I'm left with a 90t cubed, okay, plus 2 times, if I take a 3t cubed minus 7 to the 4th out, that's just going to leave this to the power of 1. So that's just 2 times 3t cubed minus 7, okay? Well, inside that second set of parentheses, I can distribute. So I'm going to have 3t cubed minus 7 to the power 4 times 90t cubed plus 6t cubed minus 14. So then y prime equals 3t cubed minus 7 to the power 4 times 90t cubed plus 6t cubed is 96t cubed, and then minus 14. Okay? Number 12, it says solve both f prime of x equals 0 and f double prime of x equals 0 if f of x equals x times x plus 9 to the 3rd. So, again, on this problem, I have a product rule where x is going to be f and x plus 9 to the power of 3 is g. So let's lay out f prime, g, and g prime. So f is x, so that means f prime is 1. G is x plus 9 to the 3rd, where something to the 3rd power is my outside function and x plus 9 is my inside. So that derivative using the chain rule is going to be 3 times that something to the 2nd power, and then I multiply by the derivative of the inside, which is just 1. So I get g prime is going to be equal to 3 times x plus 9 squared. So now we're ready to use that product rule. And keep in mind, I've got to find the first derivative and the second derivative. So for the first derivative, and I guess I should say f prime, because that's what the notation we're using. So f prime of x is first times derivative of the second plus second times derivative of the first. So my first layer on cleaning this up is going to give me a 3x times an x plus 9 squared plus an x plus 9 cubed. I have two terms, okay, and I can see that both terms have at least an x plus 9 squared, so that means I can factor out an x plus 9 squared, okay? That's going to leave me with 3x plus, when I factor an x plus 9 squared from an x plus 9 cubed, this becomes to the power of 1. So I just have 3x plus one of these x plus 9s. So if I go another layer, I'm going to have x plus 9 squared times 4x plus 9. Okay? So if I'm going to find the second derivative, let me rewrite the first derivative up here. So if my first derivative is x plus 9 squared times 4x plus 9, this is also going to be a product rule, okay, where my first function is this x plus 9 squared and my second function is this 4x plus 9, okay? Now, for the x plus 9 squared, my outside part is this something squared, okay? And the inside is this x plus 9. So when I find f prime, that's going to be equal to 2 times x plus 9 to the power of 1, and then we multiply that by the derivative of the inside. And then g prime is just going to be 4. So when I use the product rule, I'm going to have first times derivative of the second plus second times derivative of the first. Okay. Now, when I'm looking at this, I have two terms being added, and I notice that my terms at least have one x plus 9. So for f prime of x, I can factor out an x plus 9, okay, just one. That's going to leave a 4 times 1x plus 9, because if I cancel 1 out, I still have 1 left, okay? Plus, on my second term, the x plus 9 cancels, so I'm just going to be left with 2 times 4x plus 9, okay? And I can clean this up. I have x plus 9 times 4x plus 36 plus 8x plus 18. Okay. So f prime, I've been finding double prime. I've been finding that second derivative, right? So f double prime of x is going to be x plus 9 times 12x plus 54. So what we've been asked to do is figure out, well, what are my x values when f prime of x equals 0 and when f double prime of x equals 0. So when f prime of x equals 0, that means I'm going to have x plus 9 squared times 4x plus 9 is equal to 0. So we can just set each part equal to 0. I have two x plus 9s, but I only have to set one of those equal to 0 because I'll get the same result. And then I have this 4x plus 9 equals 0. So x is equal to negative 9 when I subtract 9 from both sides. On the second one, I'll have 4x equals negative 9. When I divide both sides by 4, I get x equals negative 9/4. So when f prime of x equals 0, x is negative 9 and negative 9/4. All right, so when f double prime of x is equal to 0, that means I'm going to have x plus 9 times 12x plus 54 equal to 0. So that's going to be x plus 9 equals 0 and 12x plus 54 equals 0. On the first equation, I subtract 9 from both sides to get x equals negative 9. On the second one, I subtract 54 from both sides, and I get 12x equals negative 54. Then I divide both sides by 12, and I get x equals 54 and 12 are both divisible by 6, so I'm going to get negative 9/2. So when f double prime of x equals 0, x equals negative 9 and negative 9/2. On number 13, we want to find the tangent to y equals x minus 3 over x plus 2 squared at x equals negative 1. So when we're doing this, we've got to do two things, because if I want to find the tangent, I know that eventually I will use this point slope formula. Guess I could write it like, okay, I'm going to use the point slope formula. So what do I not have? Okay, well, right now, I don't know if this is going to let me highlight like I'd like to. Right now, I'm missing a y1 and I'm missing a slope. Okay, so let's find our y1, because we have an x1. And remember, we find y by plugging x into the original equation. So y is going to be negative 1 minus 3 over negative 1 plus 2 squared. So y is negative 4 over 1 squared, which gives us 16. Okay? Trying to see if that's what I wanted. 16, negative 3 minus 1, negative 4. we'll roll with it for a second and see what happens. All right, so that's my y. When I want to find my slope, I have to first find the first derivative, so y prime of x, okay? And then I'm going to plug in my x value, right? So let's just find the first derivative. When I'm looking for that first derivative, notice that my outside function is this something squared, and on my inside function, I have a quotient rule, okay? So for the derivative of my outside, I'm going to have 2 times x minus 3 over x plus 2 to the power of 1. For the derivative of the inside, okay, and this one is simple enough, I think we can kind of think through it, okay? But for the derivative of the inside, I'm going to have low d high minus high d low over low low. So when we clean this up, I have 2 times x minus 3 over x plus 2 times x plus 2 times 1 is just x plus 2 minus x minus 3 times 1 is x minus 3 over x plus 2 squared. So y prime of x is 2 times x minus 3 over x plus 2 times, I'll have x plus 2 minus x plus 3 because I distribute that minus sign over x plus 2 squared. So y prime of x is equal to 2 times x minus 3 over x plus 2 times x minus x cancels, so I get times 5 over x plus 2 squared. So now I can multiply, or I can multiply straight across, and this gives me 10 times x minus 3 over x plus 2 cubed. So to find the slope, I need to plug in that x value of -1 into 10 times x minus 3 over x plus 2 cubed. And I'm going to replace x with -1. Okay, so that's 10 times -4 over 1 cubed, and that's going to give me -40. That's my slope. So now I have a slope of -40, and I have a point -1, 16. So we have y minus y1 equals m times x minus x1. So y minus 16 equals -40 times x minus -1, which is x plus 1. So this is y minus 16 equals -40x minus 40. Then we're going to add 16 to both sides. So this gives me y equals -40x minus 24. Number 14, we want to find the tangent to y equals the square root of x squared minus x plus 4 at the x value equal to 1. So again, I need to find a y value, okay? And we do that by plugging x equals 1 into that original function. So y of 1 is going to be the square root of 1 squared minus 1 plus 4. So y of 1 is the square root of 1 minus 1 is 0, and 0 plus 4 is 4. So y of 1 is equal to 2. So we have this point 1, 2. To find our slope, I have to find the first derivative. And we can see that this is another chain rule, where I have something to the 1/2 on the outside and x squared minus x plus 4 on the inside. So y prime is derivative of the outside, so that's going to be 1/2 times x squared minus x plus 4 to the -1/2. And then we multiply that by the derivative of the inside, which is 2x minus 1. So we can clean that up. y prime equals, if I'm looking at what stays in the numerator, it's this 1 times the 2x minus 1, which is just 2x minus 1. And in the denominator, I'm going to have 2 times the square root of x squared minus x plus 4. So y prime, well, this is simplified. So now I can plug in x is equal to 1. So y prime, when x is 1, that's going to give me the slope. So I'm going to have 2 times 1 minus 1 over 2 times the square root of 1 squared minus 1 plus 4. So 2 times 1 is 2, and 2 minus 1 is 1. And then in the denominator, I'm going to have 2 times the square root of 4. So that's 1 over 2 times 2, which will give us 1/4. Okay, now we have everything that we needed because we got a slope and we've got a point. So we have y minus y1 equals m times x minus x1. That's y minus 2 equals 1/4 x minus 1. So that's y minus 2 equals 1/4 x minus 1/4. So we'll add 2 to both sides. But if I'm going to add 2 to 1/4, that's the same as adding what? What over 4 would be equal to 2? 8 over 4. So I get y equals 1/4 x plus 7/4. Number 15, the position of a particle moving along a coordinate line is s of t equals the square root of 12 plus 4t with s in meters and t in seconds. Find the particle's velocity and acceleration at t equals 6 seconds. All right, so remember the velocity is just the first derivative of my position. Now, my position function is given as the square root of 12 plus 4t. But we know at this point, if I have a square root, I need to rewrite exponentially. And now we can see that my outside function is this something to the 1/2, and the inside is this 12 plus 4t. So if velocity is equal to the first derivative of my position, then we're going to have 1/2 times 12 plus 4t to the negative 1/2 times the derivative of the inside of that function, which is just 4. So cleaning this up, my velocity is equal to, well, 1/2 times 4 is 2 over 12 plus 4t to the negative 1/2 is the square root of 12 plus 4t in the denominator. Okay, now it is going to help us to actually keep this in exponential terms, because when we find that acceleration, we're going to have to rewrite things exponentially anyways. So we've got velocity. Let's take a second and find acceleration. So acceleration is, again, I'm going to have this outside function. It's a chain rule. And I have the inside portion. And 2 is just a constant multiplier. So I'm going to have 2 times derivative of the outside. So that's a negative 1/2 times 12 plus 4t. And when I subtract 2 over 2 from 1/2, I get a negative 3 over 2. And then I'm going to multiply by the derivative of the inside, which is just 4. So to clean up acceleration, negative 1/2 times 2 is just negative 1. Negative 1 times 4 is negative 4. And in the denominator, I'm going to have this 2 plus 4t to the positive 3/2, okay? But raising something to the positive 3/2 is the same as taking the square root and raising that square root to the 3rd power. So now let's find our velocity and acceleration at t equals 6. So v of 6 is going to be 2 over the square root of 12 plus 4 times 4. So that's going to be 2 over the square root of 12 plus 16. So that's 2 over, I've screwed something up here. Let's see. Because that's supposed to be, did I write the problem down wrong? Let's see, y'all. 12 plus 4t. So that's 1/2. 12 plus 4t to the negative 1/2 times 4. Half times 4 is 2 over 12 plus 4t. Oh, I'm a crazy person, y'all. Okay, I'm going to back it up because I know you were screaming at me. Okay. So that's 2. If I'm plugging in 6, not a 4, like I just tried to do, that's going to be the square root of 12 plus 4 times 6. So that's 2 over the square root of 12 plus 24, which is 2 over the square root of 36. And that's equal to 2 over 6, which is equal to 1/3. So at 6 seconds, and maybe we should say at t equals 6, the velocity is 1/3 meters per second, okay? For the acceleration when t is equal to 6, we're going to have -4 over the square root of 2 plus 4 times 6 cubed. So that's -4 over the square root of 36 cubed. So that's -4 over 6 cubed, which is 216. And let's see what we're supposed to get. I think here, if I divide both of these by 4, I'm going to get -1 over 54. So at t equals 6, the acceleration is -1 over 54 meters per second squared.